Hello friend, you're welcome to this presentation. I want to quickly show you how to do regression analysis in some areas in engineering using Excel. So this is regression analysis in engineering using Excel, Microsoft Excel. And as a way of providing background, I will show you possible areas of research where this regression can be applied in engineering. I remain your facilitator, Dr. Marco Ojide. First, I want to say that regression analysis is a powerful statistical tool widely used in economics and statistics, and has also been adopted in engineering to model relationships between variables and make predictions. It helps engineers understand how different factors influence a system or a process, enabling them to optimize designs, probably predict outcome, and make informed decisions. So that's the key thing here, to guide in making informed decisions. I will show you possible areas where this can be applied in mechanical engineering, civil engineering, chemical engineering, electrical engineering, and general engineering applications. So let's start with the first one, mechanical engineering. This can be applied in predicting material properties. Regression analysis can be used to predict the material strength, elasticity, and other properties based on composition, processing condition, and other factors. Maybe that is part of what we're going to do as practical here. We will look at how possibly 3 different materials can affect the strength of a pillar in a design. Now, you can also use it to optimize design parameters. Engineers can find regression models to be important or help them determine the best combination of design parameters to achieve desired performance and characteristics, such as reducing stress or improving efficiency in the design. It can also be used to predict performance. This regression analysis can help predict outcomes like stress, strain, temperature, or even vibration in mechanical systems under various conditions. As for civil engineering, this can be applied in analyzing structural behavior. Regression models can be used to predict the behavior of structures under different loads and even environmental conditions. So different loads can be modeled and different environmental conditions can be simulated, and then you run a regression to see how this affects the behavior of the structure, and then you'll be able to even know which one has more impact or not. At the end of the day, you may discover that certain conditions may be impacting the structural behavior better than others. It is also used in predicting material properties. Like in mechanical engineering, this can be applied to predict the property of construction materials like concrete, steel, and asphalt. It can also be used in forecasting engineering cost and timeline. By analyzing historical data, for instance, what we call time series analysis, regression can aid in predicting project costs and even timeline in terms of completion of certain phases or completion of the whole project, which is actually crucial in project management. Now, as for chemical engineering, regression analysis can be used to optimize the process conditions to achieve desired product quality or even yield. It can also be used to model and understand how changes in input parameters affect process output. Of course, that could allow to anticipate, and then control process behavior. It can also be used, regression analysis can be used to develop predictive models for process control. You can develop a predictive model such that when you vary a particular variable, when you change a particular variable, you will see how it affects the dependent variable, a desired outcome. So it can be used to predict, to model a predictive model, to design a predictive model for control and monitoring, and to ensure stable and efficient operation in the system. In electrical engineering, regression analysis can be used to perform, for instance, predicting battery performance. Regression techniques can be used to model battery behavior, including voltage, capacity, and lifespan. And then in the applications like electrical vehicle, you want to check how this kind of factors can affect electrical vehicle, how long this battery can last. It can also be used to analyze circuit behavior. Regression analysis can help understand the relationship between voltage, current, and resistance in electrical circuits. Optimizing power construction is another area where regression analysis can be used. The regression model can be used to estimate the predictive power of consumption pattern, enabling efficient energy management and distribution in the system designed. Now, in terms of general engineering application, quality control is key for almost every aspect of engineering, and regression analysis can be used to identify factors that can affect product quality and develop models that can maintain consistent quality standards. It can also be used in terms of risk assessment. Regression can be used to assess risks associated to various engineering projects and design, helping engineers make informed decisions about risk. Of course, that will help in risk mitigation. So these are areas it can be used. Even in forecasting and planning, regression analysis is valuable tools for forecasting future trends and planning future projects in various engineering disciplines. So let me quickly show you this thing, and then we do the practical, and that will be the end. The basic concept you need to understand here: in regression analysis, there is something called dependent variable. The dependent variable is the variable that is receiving the weights. Like if you look at this model here, this is our dependent variable. In elementary mathematics, we call it subject of the formula, and it's been affected by the factors here. The major factor here is our x. We could have x1, x2, x3, meaning different factors affecting this. This may be the strength of the structure, and you are checking how material 1, material 2, material 3, meaning x1, x2, x3. Now, but we have something here, beta 0. This beta 0 is our parameter. This beta 0 is saying if these factors that could affect strength, your dependent variable, are equal to 0, if they are not there, what level of strength will you have? And that is why it's called population intercept. What is the initial takeoff if there is no factor affecting this? So this presumes that this is a linear component. There could be models that are not linear in nature. So but this is a parameter we are estimating. We want to be able to estimate from this model what is the intercept here, or what should be the starting point if the factors in questions are equal to 0. If x here is equal to 0, x times this parameter here of x, any 0 thing 0 times 0 will give you 0. So that will mean this is ruled out. So that is our population slope, which we call the coefficient. This is coefficient. Now, but this is the independent variable. The x is independent because it's assumed that it's determined by factors outside the model. But your y is dependent because it's depending on what the independent variables are giving it. Now there is this factor here we call random error component or error random terms. We use it to represent other factors we have not included in this model that may be affecting your y. Okay, so if we have 3 materials we are working with, material 1, 2, 3, that may not be the only factors affecting your y. So we include these error terms in designing our model. The system, many softwares have been designed in a way that they capture this without you writing it in your model. All right, so the key factors that are here is your dependent variable that has been explained, independent variable that has been explained, and then the regression model. This particular equation here is your dependent model. All right, so in summary, regression analysis provides a powerful set of tools for engineers to analyze data, build predictive models, and make informed decisions, which is key in a wide range of engineering applications. Now, coming to do this in Excel, many Excel software do not come with inbuilt statistical tools needed for this analysis. So usually we add it up in our model. If you have not used it before in your Excel, you need to add it up. And to add it up is simple. You go to File in Excel, go to Option, go to Add in, and then click Analysis 2-pack. That will appear. I'll show you how to do that. Coincidentally, I've used it in my Excel here. You click on File. Okay, under File, you see More, or you see Options, and then you click on Options. It gets you to this dialog box. In this dialog box, you see Add in. You click on Add in. When you click on Add in, it pops up different options. One of them is Analysis 2-pack. You highlight it, and then somewhere down on the Analysis 2-pack, you click on OK. Once you click on OK, it will pop up something. You click on Go, for instance. Here, if you click on Go, it will pop up this, and then you click OK. Once you do that, it has added it up. If it's already in your system, if you click Data on the menu bar, you will see it somewhere here. If it is not here under your data, then you go through that process to add it on your Excel. Now, once it's added, you will be able to do certain analysis. So this is what we want to do practically. Looking at 3 materials and how they affect pillar strength. Okay, to do that, I will want to use the same process I used earlier to go and generate random data. All right, for those of you who have seen my video on how to use correlation in Excel to do engineering analysis, you recall how we did that thing. If you have not seen it, the link is attached to this. Click on it and learn how to do regression analysis using Excel. Okay, now what we want to do is to quickly generate that variable, the data. So I have written out this by myself. All right, so all you need to do, you click equal to round between. All right, if I click on round between, I tell the system to generate what I want to do. Maybe the material in question ranges from say 20 for, and then to 200 for first material. Okay, I'll click OK. Then the second material, round between, maybe it ranges from 10 to say 150. Okay, each time until I make this static. Each time I click OK, it will change randomly. So the next one, round between. But if you already have read data, that's fine for you. Okay, that's fine for you. All right, so let me say this ranges from 5 to 95. That's the third range. And then the pillar strength, let's assume that it round between, it ranges from what? Give me something. Oh, you are not giving me to. Okay, beautiful. Do it on your own, all right? If you do it on your own, you will learn a lot. Now, let me say 120 to 850. That's the pillar strength we are checking. So this has given us different variables. I'll highlight it and then drag down to generate a good number. It's always good to have a good number, maybe 25 and above. That's preferably. Otherwise, you can do with what you have. This is about 30 data range. To make sure it becomes static, that it doesn't change often, I want to remove this formula by clicking copy, Ctrl C. Then I will go to file, not file rather, I'll go to home and then paste. Under paste, I can also right click here and then paste special as values. So this has become static. Is no longer changing with figures. So this is basically the Excel file we have for this analysis. So how do we analyze? You click on data, all right, then you click on analysis, data analysis, all right, then you look for regression here. I scroll down. This is regression. I double click on it. It gives me this dialog, beautiful dialog box, all right. The input y is your dependent variable. And which one is my dependent variable here? If you get it, you are a brilliant person. Oh, beautiful, you are there. Pillar strength. You are too much. Congratulations. You are actually doing well. All right. So let's pick it. To pick it, I'll click on this arrow up here because I want to put pillar strength there. I click on it. All right. Then I highlight pillar strength from the name and scroll down to the end. And then I stop there. I click on the arrow down to expand it. So that has recorded. But you know I started from the beginning. So I need to click that the first one was used as label. So I click on this to show that the first one was used as label. So I click on the rest to put all the X together. All right. I scroll up. I select all of them together. Then go down. I have three variables, three independent variables, right? Then I stop there. Click arrow down. It has been recorded. So where do you want this result to appear? Do you want it to appear on another a new sheet, a worksheet? If yes, you allow this and it will appear there. If you want it to appear on this particular worksheet we are working with, okay, you will indicate. So let me say give me output range and I want it to appear here. So I want to click on somewhere up there so that the result will be there. Then I click OK. And then what else? I click OK to this. And this will give me the result of the analysis. This is the beautiful result of this analysis. Okay, those of you who are interested in understanding how this can be properly interpreted, feel free to visit the link I shared on how to interpret regression. So this is basically the results. This is basically how to do analysis, and then you have your coefficient, standard deviation, t-statistic, p-values, and all of that. And then this is the intercept I had shown you. This is the material one showing negative coefficient here, which is showing that an increase in material one reduces the pillar strength. This one is showing an increase in material 2, material 3 will increase the pillar strength. And that is the end of this discussion. Thank you very, very much. The interpretation of this result using another software we call Eviews is also shared in the link of this video. Thank you very much as you do your own analysis. If you have not subscribed, please do subscribe. God bless you. Cheers.